Welcome everyone to my channel. In this video we're going to be looking at a slightly weird anomaly powering up these green LEDs, and we're going to be watching that on the amp meter just so that we can get a clearer understanding of how this system is different. And I just want to go over this quote from Arthur Schopenhauer because I feel it's very relevant. I get a lot of comments, which I do appreciate, and I encourage everyone to leave a comment, and even if your opinion is different to mine, I'm willing to discuss it and hear you out. I do sort of wish that some people would replicate the experiments that they see or that I show before leaving a comment like, I don't know what the bloody hell I'm talking about. So this keeps popping into my mind, this quote that Arthur Schopenhauer stated. I don't know when he stated it, but all truth passes through three stages. First, it is ridiculed. And that, I believe, is controlled by ego. That's what someone will see something like what I'm about to show you here. They will refer back to their education. They will feel that I'm trying to trick them. Their education states what I'm showing here is incorrect, and therefore they will take choice to ridicule me. And so I'm okay with that because I went through that process as well. And it's more of a case of doing what Tesla said and actually do the experiment. And then we can have a proper conversation, because then I understand that you understand that you were lied to, I was lied to, and now when we're on the same page, we can sit down and chat about it. Second is violently opposed, and that's also something I experience a lot, which is okay. Again, I'm fine with that. You know, there's this reliance on their ego. They keep going back to this same thing, that I'm too smart to have been tricked. So they get quite angry and they get quite aggressive usually. And again, that's a perfectly fine emotion, to realizing that you've been tricked. I just wish sometimes people would maybe focus that energy where it should be focused, on those who tricked you, as opposed to perhaps focusing on the persons who are bringing this to your attention. Third, it is accepted as being self-evident, and that is something that I have experienced myself in person, that I have shown people things over the years, and then later down the track they'll even repeat them to me as though it was self-evident. Everybody was aware of this. It's like the oh duh moment. It's just, and I'm ready for that. As I said, I've experienced that already, where people will go, yeah, what are you talking about? Everyone knows that. So, for those of you who've got to go through these phases, and I believe everything goes through these three phases. Arthur Schopenhauer, very, very wise man. Those of you who have heard of him before may be aware of his research in anti-gravity for the Nazis. Okay, so let's get on to one of these realizations, because I didn't listen to the textbooks and I went and performed the experiment. We have seen before, for those of you who don't know what's going on with this Tesla transfer concept, it is a portion of the Tesla switch, which involves mechanical switching, which is not being utilized here. So this will not have the efficiencies of the Tesla switch. With that in mind, it is exceptionally efficient. Now, through experimentation, I've found some extra efficiencies, which I'm going to demonstrate to you right here now. What I will do is I will remove these two batteries in this series bank. In a Tesla transfer setup, the power moves from the series bank. It is not all being used, but instead a large percentage of it is being transferred from this bank to this bank. Okay, so if you want more information on this, I've got a whole playlist of these videos in relation to this that I wanted to cover in full depth before I move on to the automated switching setups. But there's just so much stuff to discover along the way that unfortunately, another video. I feel it's important. It might seem to some people, it's like the oh duh moment. Third is accepted as self-evident. To some people, this will be self-evident for those of you who have been down this path. For others, they have got to be given the same opportunity as you. They need to be given that opportunity where they're re-educated. Things are different to what we were taught. Some people have asked why in the other video I had removed 2 of these batteries and stated that this would be why it was presenting a difference in amperage, and I just want to explain why that isn't the case. Initially I thought the same, but in looking into it a bit deeper I realized that isn't the case. So what happens in the transfer method is we have these 5 batteries here at 1.2 volts each, making 6 volts, and now normally that would be too much for a 3.2 volt LED. However, when used in the transfer method, this 1.2 volts of the parallel bank is subtracted from the serial bank. Now when that occurs, so we get down to 4.8 straight away there, and then we've got the drop of this diode LED, which is about 0.9 of a volt, as well as a singular diode, the green one on this side, having about the same 0.9 of a volt. So we're coming down, so what is that, 1.8 plus 1.2, so we're looking at 3 volt drop. So the voltage seen across the transfer section is, we'll demonstrate that now. Actually, I'll need to put those batteries back in to achieve that. So we'll do that. So we've got the 5 in series here. We're positive there, and the negative in the transfer sense is the positive of the parallel battery bank. So we'll clamp that on there. So that's the voltage we get there, 3.6 volts. Okay, so that's the reason why I take out the 2 batteries, to make it comparable to the conventional use of electricity. So we can see here that we started with 6, and probably I should show you that is in that range. So we go negative to positive, and so we're looking at 5.54. I hope you can see that on the screen. 5.45. It would depend on how good my connection is there. Yeah, 5.45. Okay, so, and then when you subtract the voltage, forward voltage drop of the LED, and then the voltage drop of the parallel bank, as I said before, 3 volts. So that's why I took out the 2 batteries. And I'll do that again so that we can measure that voltage. So we are looking at, with just the 3, we're looking at 2.7 volts. So I could possibly put back a single battery, and let's see, that will get us probably too high then. Oh, you bugger. Okay, so I've got that in the wrong part of that cell. That's a 2 battery cell there, holder. So we go, see, it's too high. So the reason for me removing those 2 batteries was an attempt to get a similar voltage so we could get an understanding of a similar current draw. So if we have a look at the current draw in the conventional sense before I show you this anomaly, and then it will help us to understand the gravity of what's going here on the negative, what's going on here on the negative rail. So if we place this LED in a conventional sense through the ammeter, and so we're going from positive and then we connect the other side of the ammeter to the LED. Would have been smart of me to have this organized earlier. And so that now gets connected to the negative of that battery, and we can see there that that pulls 47 and climbing milliamps. Light is nice and bright. Okay, but now if we were to connect this into this serial arrangement, into the transfer method, put those batteries back in, and we will connect up the LED at the top here. So again, positive is on the serial bank. Again, it would be nice if I had nice easy connections just to demonstrate this without question. However, I couldn't be bothered setting it up, to be honest. I know what's going on here, and I know it's not in conform, and it does not conform with the textbooks. So so now we have that LED running at 3.9. So I've put the opposite probes on there, so I'll just swap them around. We go negative to that one, which we had before, and positive to that one. Okay, so we've got the LED nice and bright, pulling 4.1 milliamps, whereas before it was 40. So now, not only that, I need to point out that we have 6 LEDs down the bottom here that are also functioning at that time. So what I'll do is I'll connect this up now, and to save you having to deal with the procrastination, I will I'll stop this recording, and then I will start again with it connected. Okay, so that's now connected up. We're running through the ammeter. The light is on there without me having to hold it. I have this little breadboard here that houses the 5 LEDs, or just 6 LEDs, sorry. So they each should be drawing the 40 milliamps that we saw before, and for some reason they only have that effect. If I remove one, you can see that there is a difference, but it's very little, next to nothing, which is slightly confusing. And yeah, this is on the negative rail again. It shouldn't have such low current draw. So in other videos we've seen, I've just had the 1. So that's what we get down to with just a single green LED. So I try and place these back in here. This is a cheap breadboard. I don't advise you buying a cheap one. I recommend you get a good one. I have tested this with a soldered set of LEDs. This is not the final number, so excuse me, there may be a number of LEDs which is a better configuration than the number I've got here. It's just a case of this is what I have tested to date, and therefore that's what I feel comfortable about demonstrating. But you'll see the flickering and whatnot there is from the poor quality connectors inside this breadboard here. So, as you can see there, it's coming up again in milliamps. You can see there is an effect, but then it's not in accordance. Let's see what happens. I'll add in this jumper to these other 6, so we can see what effect they have on current draw. Again, it's a terrible breadboard, a cheap one. Don't advise getting a cheap one. So I'll just turn off that light so you can get an idea. Excuse me again. So as we can see, yes, the amperage milliamps did increase. However, that's not relative, or it's new relative amount. Using this transfer method, clearly you cannot achieve something like that with the conventional electronics. So I get a lot of people saying, I got this wrong. This is not mine, and I need to, I have to keep mentioning this to people because obviously they've not seen the other videos, and so they're not up to speed, and so they might not be aware. They probably think that I'm trying to flog this as my invention. I'm not. A lot of my work is someone else's work. I've just been looking into it out of pure curiosity, and it interests me. So when I find something I feel is important, I want to share that with other people. Otherwise, I'm just going to go to my grave a smart-ass know-it-all that didn't really help anyone, and therefore didn't benefit from any of this. So that's what I've noticed. If you do know, I get people tell me all the time that I've got it wrong, but not why. I don't know how helpful that is. Perhaps explain to us why. There are, don't want to brag, but there are thousands of people looking at these videos now. I'm sure if you know why, we'd all like to know. Alright, thanks for watching. Please like, share, subscribe. check out my other videos if you're interested in this and you want a more in-depth understanding about it. I don't want to have to burden those who have already watched those videos by having to explain it each time, so I'm going to try to narrow that section down a bit and just focus on the new thing that I'd like to display. And then those of you who are not up to speed can catch up in your own time with those other videos. Thanks for watching. Please like, share, subscribe. Have a nice day.